Hey guys, welcome to 8.4. This section is on the finding areas of triangles when you can't do base times height divided by 2 because it's not a right triangle. Okay, so if you happen to know the side angle side measures in a triangle, you can use one of these three formulas. Okay, and they're actually pretty easy to memorize. It's 1/2 times the sides times sine of the angle between them. Okay, and it doesn't really matter which one's which. So any two sides times the sine of the angle between them. Okay, because this is for SAS. All right, so let's see what's happening here. So again, I'm going to draw the triangle. It's okay if it's not drawn to scale. We have an A, a B, and a C. Side A is 8, side B is 6, and angle C is 30. This is a beautiful side angle side, so we can use the area formula that we just talked about. So the formula is 1/2 times one of the sides times the other side times sine of the connecting angle. And then just calculate that, and that's the area. So 0.5 times 6 times 8 times cosine, nope, just kidding, sine of 30, and that area ends up being 12. We don't have units, so just units squared for area. Now, what if you have all three sides of the triangle? How do you find the area? And for this one, we have to use Heron's formula. Okay, so if you're given the three sides A, B, and C, here is Heron's formula to find the area of that triangle, where S is called the semi-perimeter. You add all the sides and divide by 2, and then that's going to be the S in the formula. So it's S times S minus A, S minus B, S minus C. Okay, hopefully there's one of those to practice. Yeah. All right, number 2. Find the area of a triangle with the given sides 4, 5, and 7. Okay, so let's start by finding that semi-perimeter. It's 1/2 times the sum of the three sides. Okay, so that looks like it ends up being 8, right? 16 divided by 2 is 8. Okay, so the semi-perimeter is 8. And then now that we have the semi-perimeter, to find the area, it's the square root of S times S minus 4 times S minus 5 times S minus 7. And then you just type that in the calculator. All right, so big square root sign, 8 times 4 times 3 times 1. I just subtracted these. And you end up getting 9.8, no units, so just units squared. All right, cool. Let's try one more, and then we'll save number 4 for class. Find the area of the shaded region enclosed in a semicircle of diameter 10. The length of chord PQ is 8. All right, so we got some geometry here. Find the area of the shaded region. So a lot of times with shaded regions, it's a good idea to find the area of the big shape and then the area of the inner shape and then just subtract them to get the shaded stuff. So the big shape is a half circle. So let's start by finding the area of this green half circle. And you guys know area of a circle is pi r squared. So this will be pi r squared divided by 2 because it's a half circle. All right, so the radius is 5, right? Because if the diameter is 10, that means the radius is 5. So this ends up being pi r squared divided by 2. So we could just call that 12.5 pi. Or you can leave it as 25 pi over 2, or even a decimal. Okay, now we need to find the inner shape, which is a triangle. And here's the good news. If you really remember your geometry, does anyone know what this angle is? If it's an inscribed angle for a diameter, or actually if you draw it this way, what does that end up being? The good news is it ends up being 90 degrees because it's half of 180. Remember, inscribed angles are always half of the intercepted arc. So good news, if it's a right triangle, we can find the area pretty easy. Just do base times height divided by 2. Okay, so the area of this triangle, if we use 8 as the base, how can we find the height? We could just do Pythagorean theorem because it's a right triangle. And this is probably a 3, 4, 5 triangle multiplied by 2, so this side is 6. Okay, so the area of the triangle is base times height divided by 2, which ends up being 24. And then we just need to subtract. So 12.5 pi minus 24, and we'll get our answer. And that ends up being about 15.3 inches squared. All right, awesome. Why don't we save number 4 for class, but feel free to give it a head start. Thanks for watching.